Hey, what's going on everybody? Hope you're doing well. In this video I'm going to help you get started with modeling in Houdini, so sit back, relax, and enjoy the show. If any questions arise or something is not clear during the tutorial, address them in the comments. 1 like equals 1 prayer for the YouTube algorithm. Let's get started. We are going to model this object. If you want to explore the project files and materials in Substance Painter, you can find them in the link in the description. We will start with the line node. On this line is based the whole mechanism of generating the lamp. And we will change the direction of the line, here 1, and here 0, length 3. At the Resample node, set the length parameter to the value 1. At the PolyExtrude node, activate the parameter, transform extruded front, transform space, global, and here, set the value to 0.2. At the reverse node, this node reverses or cycles the vertex order of faces. At a PolyExtrude node, next we will form the body of the lamp. For the distance parameter set 0.06. Inset 0.03. Activate the output front and output back groups. Add the null node and rename it to base mesh. More tutorials about procedural modeling in Houdini on my Gumroad page. Learn how to create a pillar generator, how to create a megastructure generator, how to model an escalator. Unlock the power of procedural modeling and take your Houdini skills to the next level. Access step-by-step tutorials on my Gumroad page. Next, we will detail the lamp. We will create the part that is illuminated. Add the delete node, and we will delete all the geometry, except for the one in the extrude back group. Add the PolyExtrude node, inset 0.009, divide into individual elements, and disable the parameter output side. In this way, for this length there will be 3 lamps. Next, we add the PolyExtrude node, set the distance parameter to the value 0.02, and the inset to the value 0.007. If desired, we can enlarge them a bit. Add the PolyBevel node. Set the distance parameter to the value 0.007. Divisions 3. I will slightly increase the value of the distance parameter. Return to the base mesh node, and add the group promote node. This node converts between different types of groups. We will convert the extrude front group to the edges. Add the group node and group the side faces. We are duplicating the group node. And here we will add minus. Initial merge set union with existing. Add the PolyBevel node. Select the Extrude front group, and indicate the group type. Activate the parameter, ignore flat edges. Distance 0.02. Divisions 4. Add another PolyBevel node. For the distance parameter, set 0.005 and divisions 3. Select the Extrude back group. Add the GroupExpand node. Select Group 1. Here we will disable this parameter. Return to the GroupExpand node. For the steps parameter we set the value to. Next, we will add the delete node, and delete the geometry that we have grouped. Add the group node, and rename the group to UV1. Group type select edges. Disable base group, and activate include by edges. Set the minimum and maximum length of the lines to be grouped. Now with the group transfer node, we will transfer the UV1 group to the basic geometry. Here, select the group and the distance. Add the clean node, and delete all the groups and attributes we don't need, with the exception of the UV1 group. Add the merge node, and we will check if everything is fine, and then we will add the null node and rename it to lamp glass. Next we will create the element that connects the ceiling and the lamp. Add the match size node. In the first input connect the Resample node. In the second input connect the lamp glass node. Add the group expression node, and we will group the first and the last point, and then, with the delete node, we will delete them. Add the copy to points node and the box node. Here add the value of 0.005. Add the delete node and connect it here. Delete the extrude back group. Add the Boolean node. Here select surface. Add the PolyExtrude node. For the inset parameter, set 0.004 and disable the output side parameter. Add the PolyBevel node, activate the ignore flat edge parameter. Distance set 0.025 and divisions 5. For the distance parameter we set the value 0.006. And for the inset parameter set 0.005. Add the null node, and rename it to plastic. Add the delete node and connect it to the base mesh node. Here we select the extrude front group, operation delete non-selected. Next we will add the split points node and the assemble node. Here we activate the parameter create packed primitives. And we will delete the geometry using node add. Add a tube and the copy to points node. For the tube set radius scale 0.005. Height 0.3. And columns 9. Add the match size node and the merge node. We see that our tubes are not placed correctly. We will position them in the following way. Here we set the minimum. Add the null node and rename it to stance. I will change the thickness of these supports because they seem too thin. Here we add the group node. Activate the parameter keep by normals, spread angle 50. Here we set 0, and here 1. Add another group node. Here we rename it to del. Here we set the same. Here set union with existing. Add the delete node. Here select the del group. Add another delete node and select the extrude back group. Add the assemble node, and activate the create packed primitives parameter. Add the copy to points node and the box node. Here we add 0.1. Now we will add the Boolean node. In the first input connect the delete node and in the second input connect copy to points. Operation shatter. And activate the group inside B. Here select surface. Add the delete node. Select the group A inside B, and here select delete non-selected. Add the PolyExtrude node. For the inset parameter set 0.017 and disable the output side parameter. Add the PolyBevel node. Distance set 0.02 and divisions 4. Add the PolyExtrude node. For the distance parameter set 0.013 and for inset 0.006. Next we will add the match size node. Here we will set -0.02 to lower it a little. Add the copy to points node and connect it as follows. We check how it looks. I will raise it a bit. Add the null node and rename it to clamp. Next we will organize the groups of nodes, and after that we continue to add materials, and generate the UV. Here we will add the group node. We will rename the created group to plastic. Next, we will add the color node to all the elements, and assign a different color to each element. This is because we will bake the ID map for texturing. We have finished adding colors to each element. Now we will create UV. Add the split node. Here select plastic. Add the group node. Name UV2. Activate the parameter, keep by normals, spread angle 40, here -1 and here 0. And promote the group to edges. Here we add the UV flatten node. Select the UV1 and UV2 groups. Here we add the UV unwarp node. Add the merge node and connect as follows. Add the UV layout and material node. Next, we will deform the geometry with the help of the lattice node. But before that, we will prepare the geometry for this. Add the bound node. Set divisions to 4. For the parameters lower and upper padding, we set 0.02. Next, we add the point jitter node. We set scale to the value 0.16. Here we set 0, here 0.5, and here 0.2. Add the lattice node and connect as follows. Here we set 4. The lattice node deforms geometry based on how you reshape control geometry. Add the soften normals node. With this, the node softens all your normals, and also allows you to harden the normals for the vertices part of the UV seams. Add the clean node and delete all the attributes and groups that we will not need. We will delete everything except the attributes, UV-CD and shop material path. Now add the output node. With this marks the output of a subnetwork node. We mark with red the node that changes the size of the lamp and test how it works. Next, we will create a material and assign it to the lamp. Next, I will export this object, and then I will prepare it for bake to extract ID map. Now I will reduce the intensity of the deformation, and after that I will export the lamp. Add the FBX output node. Let's choose the destination and save the lamp. Now we will prepare the geometry to extract the ID map. Then we will bake the ID map, after which we will move to Substance Painter. We will import the object, then the ID map, and we will texture it. The materials can be found in the project files. The link is attached in the description. Thank you for joining me on this tutorial adventure. Your dedication and enthusiasm in learning the intricacies of Houdini and Substance Painter are commendable. If you have any questions, suggestions, or want to share your creations, feel free to reach out. Your feedback is invaluable and fuels the creation of more content. Keep creating, keep innovating, and most importantly, enjoy the journey of limitless creativity. Until next time,